Possible causes for ground fault: circuit interrupter, or GFCI, tripping can include a grounding issue, moisture or condensation, cable damage, overload, transients, and GFCI sensitivity. Firstly, regarding grounding issues, check if the green bonding screws in the electrical box and well lights are properly installed and tightened. Ensure the grounding wires are continuous throughout each zone. Secondly, in relation to moisture or condensation, even after checking the fixtures for dryness, there may be hidden moisture or condensation inside them. Try removing any moisture-prone materials or installing additional ventilation. Thirdly, consider cable damage. Inspect the cables for any damage or nicks that may have occurred during installation. Ensure there are no accidentally punctured or exposed wires. Fourthly, evaluate overload. While using 12 bulbs at 25 watts on number 10 American wire gauge cable sounds like a low amperage load, the distance of the zones potentially 600 feet may be contributing to voltage drop and increasing the current draw. Consider reducing the number of bulbs per zone or using thicker wire. Fifthly, keep in mind transients. Surges or transients from external sources, such as lightning strikes or power outages, can trigger GFCIs. Install surge protectors or use GFCIs with transient protection. Sixthly, acknowledge GFCI sensitivity. Different GFCI manufacturers have varying sensitivity levels. Switch to a different brand or model of GFCI to determine if that resolves the issue. Troubleshooting steps are as follows. 1. Check the grounding to ensure proper grounding throughout the system. 2. Eliminate moisture by addressing any moisture or condensation issues. 3. Inspect the cables thoroughly for any damage. 4. Reduce the load by considering reducing the number of bulbs per zone or using thicker wire. 5. Protect from transients by installing surge protectors or using GFCIs with transient protection. 6. Try different GFCIs by swapping out the existing GFCIs for different models to test sensitivity. When addressing grounding issues, make sure that all ground connections are secure and properly made. This includes checking the connections at the electrical panel, the junction boxes, and each individual well light. Look for any loose wires, corroded connections, or damaged grounding conductors. A loose or faulty ground connection can create a path for stray current, which can trip the GFCI. Also, ensure that the grounding system is properly bonded to the metal enclosures of the electrical equipment. This bonding helps to create a low impedance path for fault current, which can help to trip the GFCI more quickly in the event of a ground fault. When addressing moisture or condensation issues, carefully inspect each well light fixture for signs of moisture intrusion. Look for water droplets, condensation, or corrosion inside the fixture. If you find any moisture, dry out the fixture thoroughly and seal any potential entry points. Consider using a waterproof sealant or gasket to prevent moisture from entering the fixture. Also, ensure that the well lights are properly ventilated to allow moisture to escape. This may involve drilling small drain holes in the bottom of the fixture or using a ventilated cover. Additionally, check the surrounding soil for excessive moisture. If the soil is constantly damp, it can contribute to moisture problems inside the well lights. Improve drainage around the well lights to help keep them dry. When inspecting the cables, carefully examine the entire length of the cable for any signs of damage such as cuts, nicks, or abrasions. Pay close attention to areas where the cable may have been exposed to mechanical stress or environmental factors. If you find any damage, repair or replace the affected section of cable. Ensure that all splices and connections are properly made and sealed to prevent moisture from entering the cable. Also, check the cable insulation for any signs of deterioration or cracking. If the insulation is damaged, it can create a path for current leakage which can trip the GFCI. When addressing overload issues, calculate the total load on each circuit to ensure that it does not exceed the capacity of the GFCI or the wiring. The total load is the sum of the power consumption of all the well lights connected to the circuit. The power consumption of each well light is determined by multiplying its wattage by the voltage of the circuit, typically 120 volts. If the total load is too high, reduce the number of well lights on the circuit or use lower wattage bulbs. Also, consider using thicker wire to reduce voltage drop and improve the efficiency of the circuit. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the beginning of the circuit. This can be caused by the resistance of the wire, which increases with the length of the circuit and decreases with the thickness of the wire. Voltage drop can reduce the brightness of the well lights and increase the current draw, which can trip the GFCI. When protecting from transients, install surge protectors at the electrical panel and at each well light fixture. Surge protectors help to protect the electrical system from voltage spikes caused by lightning strikes, power surges, and other transient events. The surge protector should be rated for the voltage and current of the circuit and should be installed according to the manufacturer's instructions. Also, consider using GFCIs with transient protection. These GFCIs are designed to be less sensitive to transient events and are less likely to trip unnecessarily. When trying different GFCIs, swap out the existing GFCIs for different models to test their sensitivity. Different manufacturers use different designs to detect ground faults. In many cases, you can replace a standard GFCI breaker with one that is specifically designed to avoid nuisance tripping. This is because outdoor lighting systems are more susceptible to ground faults, so those types of GFCI breakers are designed to be more robust. If nuisance tripping is an ongoing problem, you can install GFCI outlets that are specifically designed to avoid nuisance tripping. These outlets are designed to be less sensitive to transient events and are less likely to trip unnecessarily. When using GFCI outlets, make sure that they are properly grounded and installed in a weatherproof enclosure. The weatherproof enclosure will protect the GFCI outlet from moisture and other environmental factors. It's also essential to maintain the system. Regularly inspect the well lights and wiring for any signs of damage or deterioration. This includes checking the fixtures for cracks, leaks, or corrosion, and inspecting the wiring for cuts, abrasions, or loose connections. If you find any damage, repair or replace the affected components immediately. Also, clean the well lights regularly to remove any dirt, debris, or vegetation that may be obstructing the light output or trapping moisture. Use a mild detergent and a soft cloth to clean the fixtures, and avoid using abrasive cleaners or harsh chemicals. Finally, be sure to follow all applicable electrical codes and regulations when installing and maintaining the landscape lighting system. This will help to ensure that the system is safe and reliable. Electrical codes vary depending on the location, so it's important to consult with a qualified electrician to determine the specific requirements for the area. It is crucial to verify proper grounding throughout the entire lighting system. Confirm that all grounding wires are securely connected to the grounding bus bar in the electrical panel and that the grounding electrodes are properly installed and bonded. Use a multimeter to test the resistance between the grounding conductors and the grounding electrodes. The resistance should be as low as possible, ideally less than 1 ohm. Inspect the wiring for any signs of damage, such as cuts, abrasions, or exposed conductors. Damaged wiring can create a path for current leakage, which can trip the GFCI. Pay close attention to areas where the wiring may be exposed to mechanical stress or environmental factors. Use a cable tracer to identify any hidden splices or connections in the wiring. Hidden splices can be a source of problems, as they may not be properly insulated or protected from moisture. Repair or replace any damaged wiring or hidden splices that you find. Check the well lights for any signs of moisture intrusion. Moisture inside the well lights can create a path for current leakage, which can trip the GFCI. Pay close attention to the seals around the lenses and the gaskets around the electrical connections. Replace any damaged or deteriorated seals or gaskets. Consider using a waterproof sealant to further protect the well lights from moisture intrusion. Install drain holes in the bottom of the well lights to allow any accumulated moisture to escape. The drain hole should be small enough to prevent insects from entering the well lights, but large enough to allow water to drain out. Ensure that the drain holes are not clogged with dirt or debris. Consider using a dehumidifier to reduce the humidity in the area around the well lights. A dehumidifier can help to prevent moisture from condensing inside the well lights. Set the dehumidifier to maintain a humidity level of 50% or less. Check the voltage at the well lights to ensure that it is within the acceptable range. Low voltage can cause the well lights to draw more current, which can trip the GFCI. Use a multimeter to measure the voltage at the well lights. The voltage should be within 10% of the nominal voltage of the circuit, typically 120 volts. If the voltage is too low, consider using a voltage booster to increase the voltage at the well lights. A voltage booster is a device that increases the voltage of an electrical circuit. Consider reducing the number of well lights on the circuit or using lower wattage bulbs. Overloading the circuit can cause the GFCI to trip. Calculate the total load in the circuit to ensure that it does not exceed the capacity of the GFCI or the wiring. A total load is the sum of the power consumption of all the well lights connected to the circuit. The power consumption of each well light is determined by multiplying its wattage by the voltage of the circuit. If the total load is too high, reduce the number of well lights in the circuit or use lower wattage bulbs. Install a surge protector at the electrical pile to protect the electrical system from voltage spikes. Voltage spikes can damage the GFCI and cause it to trip. The surge protector should be rated for the voltage and current of the circuit and should be installed according to the manufacturer's instructions. Consider using a GFCI with transient protection. These GFCIs are designed to be less sensitive to transient events and are less likely to trip unnecessarily. A transient event is a short-duration voltage spike or surge. Transient events can be caused by lightning strikes, power surges, and other electrical disturbances. If the GFCI continues to trip after trying all of the above steps, consider replacing the GFCI. The GFCI may be defective. Use a multimeter to test the GFCI to ensure that it is functioning properly. The multimeter should indicate a voltage of 120 volts between the line and neutral terminals. The multimeter should also indicate a voltage of 0 volts between the line and ground terminals. If the multimeter indicates a voltage between the line and ground terminals, the GFCI is defective and should be replaced. Consult with a qualified electrician for assistance in troubleshooting and repairing the electrical system. A qualified electrician has the knowledge and experience to safely and effectively troubleshoot and repair electrical systems. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. When working with electricity, always take precautions to protect yourself from electric shock. Wear rubber gloves and safety glasses. Turn off the power to the circuit before working on it. Use a non-contact voltage tester to verify that the power is off. When working with electricity, it is important to follow all applicable electrical codes and regulations. Electrical codes and regulations are designed to protect people and property from electrical hazards. It is important to consult with a qualified electrician to determine the specific electrical codes and regulations that apply to the area. And voltage drop can be calculated using a formula that takes into account the wire gauge, the length of the circuit, and the current flowing through the circuit. There are also online voltage drop calculators that can be used to simplify the calculation. If the voltage drop is excessive, there are several ways to reduce it. One way is to use a larger wire gauge. A larger wire gauge has a lower resistance, which will reduce the voltage drop. Another way to reduce voltage drop is to shorten the length of the circuit. The shorter the circuit, the less resistance there will be, and the less voltage drop there will be. A third way to reduce voltage drop is to reduce the current flowing through the circuit. This can be done by using lower wattage bulbs or by reducing the number of fixtures on the circuit. When selecting a GFCI for outdoor use, it is important to choose a GFCI that is specifically designed for outdoor applications. Outdoor GFCIs are typically housed in weatherproof enclosures to protect them from moisture and other environmental factors. It is also important to choose a GFCI that is rated for the voltage and current of the circuit. When installing a GFCI, it is important to follow the manufacturer's instructions carefully. The GFCI should be installed in a location that is easily accessible and protected from damage. The GFCI should also be properly grounded. Proper grounding is essential for the safe operation of the GFCI. One should also know that GFCIs are designed to protect people from electric shock. GFCIs work by monitoring the current flowing through a circuit. If the current flowing through the circuit is not equal to the current returning through the circuit, the GFCI will trip. This indicates that there is a ground fault, which means that current is flowing through an unintended path to ground. A ground fault can occur if someone touches a live wire or if there is a short circuit in the wiring. When a GFCI trips, it is important to identify and correct the cause of the trip before resetting the GFCI. Resetting a GFCI without correcting the cause of the trip can be dangerous. If the GFCI trips repeatedly, it is important to consult with a qualified electrician to troubleshoot the problem. Troubleshooting GFCIs can be challenging, but it is important to do it safely and effectively. By following the steps outlined in this discussion, one can troubleshoot GFCI tripping problems and restore power to the landscape lighting system.